Everyone. Welcome to another class in our series AI for Humans. And during the last two classes, we've been able to identify two things: that machines are learners. Sorry about that. Machines are learners, and that if anything, one thing you also need to always identify is that data is actually key in training machines, because we've mentioned that you always use data to train machines from time to time, and machines would always learn, they would adjust, and they would relearn, right? And we also identified the difference between how humans think and how humans learn and how machines actually learn. We identified the main difference between those two. So we've always been talking about learning from examples, giving machines a lot of examples, learning from those examples, adjusting when the answer is incorrect, and getting it right. But then a very deep question would be, where exactly do the examples, right? Where do the examples come from? Sorry about this. So the examples, where do they come from? How do we get examples? Who creates examples? And this leads us to the third part of our class, which is data. So data is the source of machine learning. Yeah, data is actually the source of machine learning. So when we talk about data, let me give you a very interesting metaphor. See, this is, let's say if you did agricultural science in school, this is where you have like your field, right? And here you plant, let's say this is a field where I want to plant tomatoes. Sorry, I'm supposed to be showing you. So this is a field where you plant tomatoes, and let's put it in 3D form so you can actually have, multiple plantings on field. So just imagine that each of these parts is a tomato. Okay, so this field planting tomatoes. And data here, before we get to data, let's imagine that we have a farmer, and this farmer is a robot. There you go, the Zod guy. Yeah, so the farmer is a robot, and our robots are actually very cute, right? Yeah, so the farmer is a robot, and what do seeds or what do plants need to grow? They need the soil, and the soil must have various characteristics, but number one is the soil must be good, and the soil must be rich in nutrients, manure, and all of that. Now, think of it this way: no matter how good your seeds are, right? You might have the best seeds in the world. If the soil is bad, the seeds will not germinate. That's common sense, right? The seeds will not germinate. You can pour all the water in the world, you can give it all the sunlight in the world, the seed will not germinate. And all of these things we're mentioning, right? The water, the sun, the manure, all of this we are going to apply it into AI. So just stick with me for a minute. So no matter what you do to those seeds, if the soil is bad, you're not getting any good results. Now, how do we connect this with data? And this is the very interesting part. So you see, when we talk about data, we're simply saying, so you must have read about this in computer science and maybe junior school, senior school. Somebody defined data to you and said data is information, right? Data is information, or maybe a unit of information. So data is information. But when we say data is information, what exactly are we saying? I remember this is intuition. We're going to lead you down the path of machine learning, so you understand how your AI actually works. So when we say data is information, what we are saying is, you see, every time you take your phone and you take a selfie of you and your friend, very fine, cute looking friend, this is data. Every time you open your WhatsApp and you send a message and someone replies and you reply and someone replies, this is data. Every time you open your phone app and you say call 080126. This is data. Okay, so now you're not seeing any correlation, but just hold on. On your Apple Watch, can I do an Apple Watch? On your Apple Watch, where you check and you see your heart rate and tell you, oh, your heart rate is spiking or your heart rate is low. This is data. Okay, this is data. And what else? When you go on Google and you check for the temperature and they tell you Ontario, like Canada, Ontario, sunny, maybe 37 degrees. I think that would make people in Ontario very happy. 37 degrees, and they tell you Lagos, which is always very sunny, is say 36 degrees. This is data. So now, what exactly is the connection between everything I have done here? Let's take this up a bit. What is the connection between all of these examples? You took a selfie, you entered the WhatsApp message, you made a phone call, your heart rate on Apple, the temperature in your area. What exactly is the connection between all of this? Well, think of it like this. Whenever information is recorded, whenever information is recorded, this is data. Whatever information you record, your text messages, your pictures, your videos, this video I'm recording, all of this stuff I'm writing on this screen, the moment I save it, that is data. Whenever information is recorded, and it might be recorded knowingly or unknowingly, right? Like your RAM in your computer has cache. So like it just takes all the stuff there. You can copy. You see, when you copy stuff and you paste it, that is data. So every time you search something on Google, once that information is recorded, is data. Every email you send, data. Now, we said data is the soil of AI. However, if that data can be useless if it is not labeled. And this is where we go to the next concept, which is what? Labeling. So we mentioned data, right? Now let's talk about labeling. So what is labeling for data? Now remember we said that the soil is good and rich, right? If the soil is not good, it cannot produce any results. But if soil is good, it will give you very good results. So data here is the soil. Now, how do we label data? What exactly do we mean by labeling data? So let me give you a very good example. Imagine we have a box and we have another box. And if at this point you've not seen the connection, just hold on. You will make sense of it very soon. In this box, we have pictures, lots of pictures. So let's use an arbitrary number, 256 pictures, which is not so arbitrary, but you get the point. And we have in this other box pictures. Now, let me not draw this one yet. In this box, someone tells you there are pictures of dogs, cats, and mice in this box. But we don't know which one is a dog, we don't know which one is a cat, we don't know which one is a mice. Everything here is just full of pictures, right? This is what we would call data that has not been labeled. The data is there, but it's not labeled because all of the pictures there do not have, we don't know which picture is which, right? But think about it in this case, where we now have 3 boxes, and we say these boxes, there are 3 boxes. In box number 1, we have pictures of dogs. In box number 2, we have pictures of cats. And in box number 3, we have pictures of mice. What have we done there? The difference between this data and this data is that this is not labeled. And this is labeled data. That's the difference, right? So this is just a random box. It's a box full of random pictures. And this is a box that has, labeled pictures, right? This is one of the most underrated jobs in AI. Like labeling is very key, right? Because for you to be able to properly help machines learn, they need to be labeled. The data needs to be labeled for machines to be able to easily tell differences. Right. I remember when in episode 2, we talked about the dogs. Episode 1, we talked about 10 million dogs, right? And which type of dogs is it? The German Shepherd. And you have to give it like a lot of examples. So remember we said that machines learn with examples. So now think of it where the machine wants to learn with an example and we just feed it the wrong example, right? Remember, it's not a human. So it sees something over and over and over again for it to be able to say, okay, this is correct. So we have to give it examples, and these examples have to be labeled. It means if we are showing the machine a picture, draw a picture for the machine, we have to tell the machine this is the picture of maybe a house. If we are giving that picture, we have to tell it that this is a picture of maybe a dog. We need to be very explicit with our labeling so that the machine fully understand the scope of its assignment. Now, let us go back to the soil analysis. We have 2 types of soil, as we already said. We have the good soil and we have the bad soil, right? Now, what is the difference between good soil and bad soil? Well, here is simple. Good soil is soil that has all the nutrients. It is filled with pure manure. It has nitrogen, oxygen, whatever all of that is. So it has all the O2, the nitrogen. Don't know if I'm getting that right, but whatever. No, NO2 is not nitrogen. Ignore that. Point is, it has nitrogen. Right. Okay. Now, what is bad soil in this case? Bad soil would have stuff like salt. We don't need salt in your. So imagine your soil is made up of salt water. It's close to the salty side of the sea. Salt water, it has stuff like rocks, or the soil is dry, it doesn't have moisture. This soil cannot produce good fruit, right? So your whatever you're planting on that soil will struggle to grow. So same with data. Bad data produces bad AI, right? Bad data produces bad machines, but good data produces good machines, just like good soil produces good fruits. And how do we explain it? Well, think of it this way. How can we identify when data is bad? So, number 1 is incomplete data. So, if data is incomplete, this is bad data. And what is an example of incomplete data? Imagine we have 2 countries. So there is Nigeria and there is Ghana. They're always fighting, right? And we want to train a machine on jollof rice. And this is probably going to get me. Boss, if you're Ghanaian, don't worry. I promise you I'm not going to pick sides. I'll try. We want to train the machine on what jollof rice looks like or what jollof rice should taste like. I might not know the taste, okay, but we want to change the machine on what jollof rice looks like, right? And then we want to help the machine. So we want to create a machine that any picture of jollof rice you show it in the world, it can easily identify that this is jollof rice. Any picture of jollof rice show it in the world, this is jollof rice. So we want to now show it, okay, let's start with feeding it with African jollof rice, right? African jollof rice. Then we'll go to European jollof rice. Now I want to start with African jollof rice. Like, okay, which type of jollof rice do we want to feed it? So remember, there are many countries in Africa. So we can have Senegal, can have Gambia. These guys are chill. They don't argue with us about jollof rice, so they are good, right? We can have what other country in Africa? We have Egypt. I don't know if Egypt has jollof rice, but you get the point. We want to feed it. We want to show the machines all types of jollof rice pictures. So anytime he sees jollof rice, he knows that this is jollof rice. And every time he sees white rice, he knows that this is not jollof rice, right? And then we only show our machine, which is in this case, our very cute robot. And we only show our machine Ghana jollof, which is a taboo, I'll be very honest, because why would you do that? But then we only show the machine images of Ghana jollof. images of Ghana jollof. Images of Ghana jollof. We don't show it any image of Nigerian jollof, Senegal jollof, Gambian jollof, Egyptian jollof. I mean, you might not show it all these three, but you should have shown it Nigerian jollof. But we only show it images of Ghana jollof. So it processes this. It processes this. It processes all of those images as jollof. So now it knows that whenever I see these type of images, I know that this is what? Jollof. What is wrong here is that we fed it incomplete data. We did not show it other types of jollof. So what will happen is when the machine sees one of the best jollof rice in the world, I don't know, we can disagree with that. When it sees Nigerian jollof, it would say that this is not jollof. And to say it confidently because it believes that this what it has is like all the examples of jollof in the world. So it will say it confidently, and it will say Nigerian jollof is not jollof. When it says Senegalese jollof, it's going to say this is not jollof because it was not trained on all types of jollof. It was just trained on one type of jollof. And this is a very bad way to train a machine. It won't work anywhere else. So that's one very interesting example, right? Now, how about biased data? So we talked about incomplete data. Let's talk about biased data. You know, when we say someone is biased, we're just like in Nigeria, we call it ojoro. So you're picking a side. This is not fair, right? So that's the idea of biased data. So what exactly does, when we say biased data, what does that mean, right? So a very good example here is that let's imagine that we're training the AI on what a good employee is. So we want to teach the AI how to identify a good employee. And then what we did was we only gave it examples. We're like, okay, these are the aspects, these are the attributes of a good employee. So this is the machine. And we're telling the machine, every time you want to identify whether an employee is good or bad, right? Every time. These are the things you should look for in a good employee. Number one, look for the employee's age. My pen's acting up. Look for the employee's age. Look for the employee's height. And look for his department. Now, pay attention to this because this will be very key. Look for his age, height, and department. So maybe the employee is 21, is 6 foot, and then he's in what? Sales, right? So say look for his age, and then we want to give it examples of employees in which department. We want it to be able to look at the age, height, and department and tell us if this employee is a good employee. Now, this is a very terrible example, right? But just flow with me. Now, we now fed the machine with examples. Remember, we're saying we want machines to be able to predict. So when we give it examples, so that if it sees something it has not seen before, it can easily classify, right? Good. So that's how you can taste, for example, this is how, remember how humans learn? How do you taste soup and you know, oh my God, this is egusi soup or this is afang soup? It's because you've tasted it before. So using those examples, you can predict. So now look at the machine here. We want it to be able to predict based on these examples. So this is biased data. And what do you mean by biased data? Imagine we fed the machine only examples of employees whose age falls between 21 and 30. Those are the only examples we fed it, right? We did not feed it any examples of employees between the ages of 31 to 60. We didn't do that. And I'm not going to height and department, but let's imagine that this was the first bias we had in our data. We didn't look for other good employees that were fell within this age range. We only gave it employees within the age range of 21 and 30. Do you know what that does? It means anytime the machine sees somebody who is 32, it would automatically assume that this employee is a bad employee. Do you get that? And if you see someone who is 45, it's just assume bad because all the examples it was shown were from 21 to 30. Now, in actual implementation, it's a lot more, deep. It's deeper. But remember what we're talking about here is AI for humans. So we want you to get a basic idea of what is wrong, right? So biased data is when the machine is not trained on all possible types of scenarios. It is just trained on one type or a few types that does not represent the whole, right? That is a very big problem in machine learning. And this is why your AI sometimes could be wrong. Now, let us also look at the third type of data, bad soil data. Remember, we're talking about soil as data. And that is data wrong. Sorry, this is, I don't know what's wrong with my pen. Wrong labels. So this is very simple. If I tell the machine that the image of a dog is actually a cat and the image of a cat is the dog, right? I don't label it correctly. What will happen? Simple. The machine will just simply output wrong information. It's in computer science, it's called GIGO. Garbage in, garbage out. So if you give it garbage, it will return garbage to you. So that's the wrong label. So remember the three we considered. Incomplete data. You don't feed it all the data. Incomplete. Biased data. You only give it a very small representation of what is actually happening in the big deal. That's very wrong. And then wrong labels. You give it the wrong description for a right picture. So now that you have a basic understanding of how data works, this is why you see where we say, oh, companies that actually have the best AI models, Google, Amazon, OpenAI, Anthropic, these guys have data, like a lot of data. And that's why Google is a very, very big frontier in the machine learning in AI. Because imagine all the articles you've written on the internet, all the pictures you've uploaded and all of those things. Google has that data, right? So they were able to train their AI with all of those examples. Now, question is, when we have all the data in the world, right? When we have all the data in the world, what is wrong? We have all the data in the world. What do we do with it? And now, I want to take you through our timeline so that you understand where we are coming from and where we are going. Remember, we said machines train with examples. Examples are data. What do we do with data? Simple, we build models. And while data is the soil, this is the core of artificial intelligence. And I promise you for the next episode, I'm going to explain models in such a way that even a 10-year-old will understand it with very visual examples. So I hope you got the whole gist of what we've discussed. And remember when we started from, we said machines would learn by try and error, right? But for them to learn by trial and error, they need data to inform their decisions like, oh, this is correct and this is wrong. And we also talked about what could make your data bad. If your data is not complete, if your data is biased, Ojoro data, or if your data is what was the third one that we mentioned? Your data is incomplete, your data is biased, and your data is bad. So like we call a dog a cat, or we call a cat a dog. Right now, let's imagine that your data is good. You have very good data. This is where we are going to build a model. And next class, we're going to discuss that. Bye.